Hello, everybody. We made it. Last talk of the day, last talk of day one. I appreciate everybody for sticking around, coming to check out my talk. This is a really exciting talk for me to give, something that I've been really looking forward to as I've been preparing this talk, kind of reflecting back on all of my time here at GopherCon and how this particular project has been kind of so ingrained with this conference in a lot of different ways. So it's really cool to be able to tie these two things in together. I really want to thank the conference organizers for putting on such an amazing conference and for inviting me to come speak. I really appreciate the opportunity to be here. It really means a lot. So my name is Derek Parker. I'm the creator of the Delve debugger for Go. I'm a principal software engineer at Red Hat and the tech lead for the Go toolset team there. The title of this talk is A Decade of Debugging. I'm not going to be talking about a single bug that I've been working on for an entire decade, although sometimes when I'm working through a problem, it feels like I have been working on a bug for an entire decade sometimes. So since this is the 10th anniversary of GopherCon, I wanted to kind of tie in something really cool that it's also the 10th anniversary of the first time that I announced the Delve project. And one of the coolest tie-ins, I think, actually is that there was inspiration from the first GopherCon that kind of was one of the catalysts for starting to work on this project. So there's a lot of neat history between this tool and the conference. So it's really a huge honor for me to be up here talking to everybody and to be at this 10th edition of GopherCon. So I created this logo here, A Decade of Debugging, with the help of my wife. And neither of us are graphic designers, as I'm sure you can tell. Came out pretty well, well enough for the slides. But since we're kind of living in the future now, I thought initially I would try to enlist some help and get AI to help me out with some logos. And turned out kind of weird. I intentionally put the quotes around art because it's subjective. Um, these are only some of the examples that I was able to create. So the funniest thing to me about some of these pictures is I used the word debugger intentionally in the prompt when I was trying to create these images, and there's not a single instance of that word being spelled correctly on any of these pictures. So if we're worried about Skynet taking over everything and the apocalypse happening, I think we're a little bit, at least a few years away from all of that. So the bulk of what I want to cover in this talk is I want to take a look back through time, and I want to call out a lot of my favorite features that have gone on over the years, just to kind of honor this big milestone of 10 years of the project. And again, it ties in really nicely with it being the 10th edition of GopherCon. So I've attended every single GopherCon since the very early Denver days. And as I mentioned, the first GopherCon was a huge catalyst for not only myself, but had the original inspiration for me starting to work on this project. So the story kind of goes, there was supposed to be a speaker, and they bowed out for whatever reason. So they ended up replacing that talk with an impromptu kind of panel with some of the Go core devs. If memory serves, I think it was like Rob Pike, Robert Griesemer, maybe Russ Cox, and Andrew Grand, something like that. I might have messed up some of the names, but it was essentially that kind of group. And during the course of that discussion, the topic of debuggers came up, and somebody on stage mentioned that none of the tools that were currently out there were really doing a good job. So I essentially left the conference that day and had this idea, this inspiration that maybe that's a gap that I could kind of fill in, and I was inspired to start working on this tool. I had no existing experience working on a debugger, but the great thing about this community, not only the Go community, but the open source community that we have, is if you really want to learn anything, there's code out there, there's examples, there's documentation. If you really want something enough or want to learn something enough, you can read code, you can really get yourself there. So That's also one of the things that I really appreciate about this conference in general is just the willingness for everybody to come here, share knowledge, and teach, and kind of show off expertise, and the ability for everybody to kind of learn from other folks. So as we look back, what I want everybody to kind of take away from this talk is not necessarily me up here bragging about some of the interesting features that I've had the pleasure to either work on or review over the last 10 years. It's really an opportunity to reflect, look back year by year, and maybe there's a few features here or there that you've missed along the last few years. That's something that you can use and add to your own personal toolbox if you're using this tool day to day. So with that, let's go all the way back to the beginning of 2014. So we're going to go through 10 years worth of development, and so I'll do my best to condense it into this talk. So 2014 saw the initial release of Delve. I had been working on it for a little bit out, just in personal time and everything like that. But this is the first time that I announced it, like on Golang Nuts, the popular mailing list for Go. And I think I also tweeted about it. And so it was very, very exciting. Initially, it supported all of the typical things that you would expect a debugger to have. You could continue the process, you could step over function calls, you could print the value of variables and get a stack trace depending on where you are. But one of the real killer features was the ability to support following Go routines across threads, right? So amongst other things, that was one of the big shortcomings of existing tools. Thinking of the thread as the smallest unit of execution, whereas in Go, we have Go routines, which are by the runtime scheduler moved across different threads and things like that. So I want to go ahead and show a quick example. So here we have a program that spins up 10 Go routines. Each Go routine sleeps, and depending on the branch condition, it'll print hello world to the screen. And then at the end, we have a wait group, wait to kind of sync everything up. So we start the debugger just by using DLV debug, and we can continue to a specific location. Once we're there, we'll type out Go routine to see the current Go routine we're on. And if you notice, the thread that we're on, and then the Go routine that we're on underneath. Then when we go down, we next over asleep, we can see that our Go routine has migrated to a different thread, but we've followed the same Go routine over that next operation. So your thread of execution has stayed the same and consistent, even though our Go routine has migrated to a different thread. After that, we jump forward to 2015. 2015, the project had already been announced, and it was starting to gain some traction. And 2015 was the year that I gave my first GopherCon talk. So there I am, preaching the gospel of debugging, thou shalt not print line, and trying to bring this tool to the world. I was so incredibly nervous to give this talk that instead of standing in front of this podium, I was walking back and forth the entire stage. And a few years later, I looked at the YouTube video of it, and the first comment was the poor cameraman, because they were just like this the entire time. And in the notes sent to speakers from the conference organizers before this talk was, please stand in front of the podium at all times. And I have to think that rule was made for me. So 2015 was a really big year. We delivered a lot of really cool features. So we implemented a JSON RPC client-server interface. We added the set command to be able to set the value of a variable. We added the source command to be able to source some Delve commands, and the init flag to be able to start up a debug session with a series of commands that have already been pre-written. We added support for multiple levels of struct nesting during variable evaluation, added some improvements to the stack trace command, added the ability to manipulate stack frames a little bit more, the ability to learn more about the Go routine that you're on, some config options, and also the ability to do a headless server that you can connect to remotely to enable remote debugging. So the few that I'm going to focus on in the next example video is the set command, source, or actually the init flag, the full flag for the stat command, the goroutine command, config file for aliases, and the remote connection. So here we have another basic program that just calls a few different functions, and we have an init file on the right that we're going to pass into Delve on startup. Just sets a few breakpoints and continues the process, because typically when you start your debugging session, it's going to be stopped at the first instruction. So we start our headless debug server over there, we connect to it in another terminal, and we pass that init file along with. Once we're there, we set the value of a variable to 30. We alias continue to yeet, and then we go ahead and yeet ourselves over to the next function. And finally, we get a stack trace that's annotated with all of the local variables that we have there, and we can see the result of our set earlier, where we have I is equal to 40. After we set it to 30 and plus 10, it results there. And you can also use the frame command as a prefix command, so you can execute a command within the context of a different frame, and we kind of show that at the end there. The next example, we have a program that spins up 10 different Go routines. They simply print out a little bit of text and sleep, and then we sleep at the end to wait for everything to kind of wrap up. So we start our debug session again, we continue. Once we're here, we check out the current Go routine that we're on. From there, we take a list of all of the Go routines that are currently running in our program, and you get a lot of information about them, the ID, where they are, and what they're kind of doing. Are they doing garbage collector stuff? Are they just sleeping? And then we use the Go routine as a prefix. So for Go routine 37, we print out the stack, and you can even chain prefixes. So we can say Go routine 37, frame 2, list. So a lot of the commands can really be kind of composed together in really interesting ways. Moving on, we go to 2016. 2016 was somewhat of a quiet year. We did a lot of focus on stability, bug fixing, and incremental improvements, but we did manage to ship some exciting features. One of the biggest was Windows support. We finally added that 2 years after the initial launch. We added the step instruction command to step past the single CPU instruction. We added the expression evaluator, which is a very powerful feature of Delve, where you can print complex statements. You can even reslice variables and things like that, all during the in the context of the debug session. And we also added conditional breakpoints as well. So the three that I'm going to focus on in the next example are step instruction, the expression evaluator, and conditional breakpoints. So here again, we have another relatively basic program. We have normal Go code on the left. We have a little bit of handwritten assembly on the right. We're going to go ahead and, just as we've done before, start up our debugging session, continue to our assembly function, step instruction one by one, and you can see we're just going one CPU instruction at a time. We'll step out to get back to where we were before. And we'll go ahead and set a breakpoint on main.go 10, but we'll add a postfix if condition, and we'll say only stop at this breakpoint if the value of A is equal to 3. And you can see once we land there, that is actually true. And that just shows you a little bit of a taste of the expression evaluator. So print and some other commands can take complex expressions, evaluate them, and you can even like index into slices, reslice slices, slice strings. There's a lot that you can do. It's a really powerful tool. From there, we move on to 2017. And this year is a pretty exciting one. Some of my favorite features that are in the Delve debugger have kind of came out of this year. So we added support for core files. We added breakpoints on unrecovered panic, which is one of my all-time favorite features. So if you're debugging your program with Delve, you're running along, and it panics and crashes at some point, the program won't automatically exit. you still stay right there at the very beginning of that panic. So you have the ability to execute a stack trace and kind of see what's going on while all of the program variables and all of the memory and everything is still live in your program at that time. We also added the disassemble command, so you can take any function, disassemble it, and see what the actual CPU instructions are that are executing for that function. And finally, we added one of my all-time favorite, which is Mozilla RR support. So it's a deterministic record and replay debugger that allows you to basically record the execution of your program and replay it back under a debugger. And every single time you replay back that recording, it'll be replayed back faithfully. So for example, if you have a bug that only shows itself 1 out of every 100 runs, if you can capture it that one time, you can replay it back indefinitely, and you can always have an example of it to try to figure out what's going on. So in this example, we have a little program that does a lot of things that should be different for every single run. So first, we're opening up dev random and we're reading that into a buffer. We're getting the current time and we're getting the process ID of the current process, and we're printing all of that out at the end. So to use this feature, you can just say delve debug with a backend as RR. And you can see in the initial print statement, the series of bytes that we read from dev random, the timestamp that we have, and then the PID at the end. Now, when I continue the program, you can see we get the same exact output that we had when the program was first run and recorded. When we restart the process and continue it again, the exact same output is coming out. So every time you rerun this recording, everything is going to be exactly the same as it was in the first instance that you ran it. And so you can really kind of focus on solving some of those hard to catch bugs. Moving on to 2018, we find ourselves in another really interesting and exciting year. So we added support for separate debug information. This is really important as a lot of distributions, a lot of Linux distributions in particular, will strip the debug information from a lot of the binaries that they ship, and Delve gained the ability to take advantage of the separate debug information so that you can still debug these binaries. We added a few new commands up and down to navigate stack frames a little bit easier. We added the edit command to be able to open your editor pointed at the location that you are stopped at in your debugger. A huge one was we added the ability to call functions. So this is a really cool feature, and it requires some coordination with the Go runtime itself. So I want to pause a little bit here and say a huge thanks to the Go team, the Go runtime team, for all of the collaboration on this feature and ever since to really make the Delve experience work seamlessly with Go programs. We added support for CGO stack traces, which are really interesting because you have to stitch a lot of things together. And very excitingly, we got to our first 1.0 release. So this was 4 years after the inception of this program. And it took a little bit of time. We probably could have done a 1.0 release before that, but we wanted to really clean things up and make sure it was ready to go. So the thing that I'm going to call out right now is the ability to call functions. So here we have another basic program. We have our main, it's calling a function, that function is calling another function, and so on and so forth. So we'll start up our debug session. We'll continue to location in our program, and we're just going to use the call command to call our function. And we're going to pass it 24 and the string, hello, GopherCon. You can see right underneath that, the output of calling that function, and then we go back to where we were before we called that function. So there's a lot that's happening underneath the hood here. We're coordinating with the Go runtime. We actually have to work to allocate that string in the target memory. So there's a lot of really cool technical features that are going on underneath the hood to make this happen. And I think this is a really cool feature because it allows you to feel more interactive when you're with your program while you're inside of a debugging session. Continuing on, we're going to go to 2019. 2019 also added some really cool features. I'll probably say that a lot because these are all kind of some of my favorite features, so I think they're all kind of cool. One of my favorite is the ability to script the debugger. So we use a language called Starlark, which is a Python-esque language. You can define your own commands and basically write your own very custom, very complicated commands to do whatever you want, all with this kind of interface. We had the ability to read GoRoutine ancestors, so that was a feature that was added around this time, where you can actually trace this GoRoutine was created by this GoRoutine, was created by this GoRoutine. You can get in all the information all the way back. We added support for pi binaries, the ability to decorate stack traces with deferred functions, and the deferred command, which allows you to execute a command within the context of a specific deferred function. The feature that I'm going to highlight right now in the next video is Starlark scripting. So on the left, we have the example program that we somewhat of the example program we saw earlier. We're going to read from dev random, turn those bytes into a uint64, and if it meets a certain condition, we'll stop at a breakpoint. And on the right hand of that, before it turned away, was a Starlark script implementing this flaky command, which will essentially rerun the program a bunch of times until it hits a certain condition, at which this case is the breakpoint. So that's just a taste of what you can do. The scripting language is extremely powerful. There's a lot more than that you can do with it. The next release, again, was relatively quiet, but we added a few cool user-facing features. And one of my personal favorite features kind of benefited from our IDE support. So we added the reload command. We added the examine mem command, which is the ability to examine raw bytes, raw memory in your program. Display, which is a helper command to print out the value of some expression every time you stop. We added support for a few new CPU architectures, and we added built-in DApp server. Now, again, I want to call out the collaboration on this. The folks who work at Google on the code team who maintain the VS Code Go plugin worked with us to develop this DApp server. DApp, if you're not familiar, is a debug adapter protocol. And so this is really helpful for integrating with IDEs. So if you're not aware, if you've ever debugged a Go program in VS Code or Golang, or even an extension in Vim or Emacs, even if you don't know it, you're using Delve behind the scenes. Delve is the behind the scenes debugger for all of these different editors and IDEs. What we're going to focus on in the next video are these three commands: examine mem, display, and the DApp server. So we have a really kind of basic program here. Doesn't really do much, but I just want to highlight the integration with the IDE. So we set a breakpoint there just by clicking in the gutter. We're going to start the debug session by using the run and debug feature in VS Code, and we're going to use the UI to kind of step around our program a little bit. One key difference between running Delve at the command line versus in an IDE, when you start a debug session, it's going to continue the process for you automatically. So it's good habit to kind of set your breakpoint initially where you want to stop. Next, we're going to jump back in on the command line, continue to our main function, go forward a little bit to where we want to be, and then we'll use the examine mem command to examine the raw bytes of our local variable here. So we're going to do the raw bytes of the address of A. We'll add a display for I, and every time we step through our code here, you can see that it gets displayed every time. So it's just a neat way to kind of conveniently, if you find yourself printing out the value of an expression or a few different expressions every time you stop the debugger, it's a quick way to kind of automate that a little bit. Continuing on to 2021, we're getting closer to present day. It's a year after all of the COVID craziness, so we added quite a bit of features because I think we were all just locked inside with nothing else better to do. So around that time, we added supports for generics, watchpoint support, and a bunch of other different commands. Support for Debuginfod defined, eBPF-based tracing backend, and a bunch of other really cool features. The ones that I'm going to go through right now is generic support, watchpoint support, fuzzy completion for locations, and some really cool things that you can do with breakpoints and filtering Go routines. So first, we have a basic program. Again, just has a little function that it calls, and we loop a couple times and print the value of that out. And we're going to take advantage of some of the fuzzy completion stuff to get to main.main. So you can just type continue mama, for example, hit tab, and it'll complete it to main.main. That works with any symbol in your program. We'll next a couple times, and we're going to set a watch point on the I variable. And we're going to say -w to say, let me know anytime the value of that variable changes or is written to. We'll go ahead and set another breakpoint here, and we'll add a condition on that breakpoint and say, I only want this breakpoint to stop if it's been hit 2 times. So the 3 there is a little, the syntax is a little bit confusing, but 3 is the ID of the breakpoint, and we're saying anytime breakpoint 3 has been hit twice, I want it to finally activate. Here we have a generic, a couple of generic, or one generic function, and it's been initialized twice. So we have 2 different versions of this generic function. We're going to go ahead and show how we can start the debugger, list out the 2 different instantiations of this generic function, set a breakpoint on the generic function, and you can see it's setting it at both different types of it, depending on the different instantiations with the different type. And you can go ahead and actually set a breakpoint there, continue there, and be able to take advantage of the generic functions in your program. And then finally, we list out all of the Go routines, and we group them by which ones are running and which ones are not. There's a lot of other filtering that you can do with Go routines. This is just one that I kind of wanted to highlight. Going into 2022, we're only 2 years away from present time. Life is getting back to normal, but we're still working on some cool features. We added support for like function call support on ARM64, autocomplete for local variables, and a few other things. This was a relatively quiet release, but added some cool features anyways. The one that I want to call out is using Debuginfod to be able to download source code. So as I mentioned before, a lot of distributions will ship binaries that are stripped, but they will have a separate debug package that exists and can be downloaded and contains the source code and all of the dwarf debugging information that you need to debug your process. So we're in a little Arch container here. I have Delve mounted in, but I'm also installing the system delves and this Debuginfod binary. We're going to go ahead and we're going to use Delve to debug itself, and then we'll kind of see behind the scenes what's happening is all of the debug information and the source code is being downloaded on the fly as we're debugging this program. And so we can see now we have source code, all of this stuff. None of this is locally on the system. It's all being downloaded by Debuginfod on the fly. Okay, back to 1 year ago, 2023. Some of the big features that we had is improving support for stripped binaries, adding Linux PowerPC 64 LE support. We added the ability to list all of the Go routines that are waiting on a specific channel, and we added the ability to debug multiple targets, so multiple processes at the same time. So I'll highlight these 2 features right now in the next video. So we have a program here that takes a command line argument. If the argument is spawn, it'll spawn a new version of itself, essentially. If the argument is child, it'll call the trace_me_to function and kind of print out some stuff. So we'll go ahead and we'll start our debugging session, and we'll pass the argument spawn to it. So this will force the program to fork a new process. We're going to enable this feature by saying target follow exec on. So this is telling Delve anytime this program execs another program, start debugging that program as well. After we get here, we can list that out, and we can see now we have 2 programs, 2 processes that we're debugging. We can switch to the other process. Just like any other session, we can set a breakpoint. We continue. And now when we print out the variable of OS_args, we should see that now we are in fact in the child process. Here we have an example of a program that creates a bunch of, Go routines, passes them a channel, and kind of waits for them to finish executing by closing out on that channel. We'll start our debugger, continue to main.go 18. We'll print out the value of that channel, and you can see at the very bottom there, it lists out all of the different Go routines that are waiting on that channel. So this could be a super useful feature if you have a very highly concurrent parallel program, and you're not sure exactly what's going on. You can see exactly what's all of the Go routines that are waiting on this different channel. Then you can switch to them and start examining what's happening there. Finally, we get to the present day. So a few cool things that we've done so far is we've added a new feature to the trace subcommand for Delve, which allows you to follow functions that are called by it. So follow through to child functions. I'll show that in a second. And we've also added most of the support. There's a few more pieces that need to go in for the range over func support. So if anybody's excited for the 123 release, one of the big new features is the range over func that's kind of been there but hidden a little bit. We're adding support for that as well, so that'll be ready by the time the next release comes out. But if we look through at our tracer, we can see we have a bunch of functions here that kind of call each other in different interesting ways. So we can start up Delve in a little bit of a different way. We're going to start it in trace mode. So instead of a full interactive session, it's just going to kind of spy on the program like strace does and see what's going on. So we trace main.main, and we only saw the execution of main.main. Now, if we supply the follow calls and we set a depth of 3, you can see we're seeing what main.main is doing, but also all of the different functions that it's calling kind of down to its tree up to the certain depth that we specified. So with that, we get to the present day. And now we're here at GopherCon in Chicago, and we've had the opportunity to take a look back at all of the different features that have evolved over the last few years. With all of these 10 years behind us, I'm really looking forward to what the next 10 years will bring, not only for the Delve project itself, but also for GopherCon. I'm definitely looking forward to the next 10 years of conferences. None of this would have been possible without the help of all of the different contributors and collaborators on this project. This is definitely far from a solo effort, so I really appreciate the help of all the community, not only the people who directly contribute, but file issues, use the tool, and everything like that. It is extremely, extremely appreciated, and none of this could have happened without everybody's support and the love of the community. So with that, I want to wrap up now with a few words that I want everybody to kind of walk away with. The first is continue to go learn. Continue coming to these conferences, watching these talks, learning as much as you can. Don't be afraid to go out there and read a bunch of source code. Do whatever you need to do to kind of expand your knowledge. Work with other people, all kinds of stuff. Always continue to learn. The second, once you've learned enough, go ahead and teach. Come up here, give talks, pair with somebody else, share that knowledge. That's one of the beautiful things of having a community like this, is that we can all get together, we can teach each other things, and really have this kind of collaborative community that we have. Finally, go debug your programs. Fix your bugs. Lastly, please go enjoy GopherCon 2024. Thank you so much.